Hello everyone. Today I'll be showing you just how easy distributing systems can be. To show this, I'll be starting a MySQL, a Postgres, and a Kafka instance. In fact, let's just do that just now via Docker. So without starting MySQL, Zookeeper, Postgres, and Kafka, uh, let's give it a bit of time to start up. And in the meantime, I'll show you around the application. So Spring Pet Clinic is a Spring Boot application. In fact, that is the basic showcase for how simple it is to create uh, simple applications within the Spring Boot framework. We chose this application because it's familiar to most and people understand the inner workings of it. So when we say it's as simple as taking a few configuration files and adding a few modules into POM XML, it can show that we actually mean that. So how do we actually do this? Let's look at the heart and soul of any Spring Boot application, which is the property file. In the meantime, I think things have started up. Yeah, so let's start our application servers whilst I'm showing you around. So this is the MySQL configuration. We'll be running two separate instances, as I'm sure you could tell by now. A Postgres and a MySQL instance, they will be running over different ports and they will be working over different databases as served by Docker. The difference is mostly in the property file. No, only in the property file. The property file tells us, so this is the profile of the Spring Boot application. As you can tell, this is called MySQL 1, and it has a partition ID, yada yada. It's not particularly interesting. What is interesting is this part, which is called the namespace within a catalog. And what it says is that it's subscribed to a namespace called Pet Clinic, which is defined by the schema file. And that's in fact, and that Postgres subscribes to the same Pet Clinic schema file. So that essentially they share this namespace and both of them can commit and read each other's changes atomically over our shared Kafka cluster with a very low overhead. Let's look at the schema file. The schema file is just a YAML-oriented definition of SQL schema. So what we say is there are some restrictions. So for example, we require a primary key column. Now, when we say we require a primary key column, we actually mean a primary key column. So we enforce unique indexes across the whole of the cluster. So these are enforced if two different instances are trying to commit the same primary key in parallel, then only one of them will be accepted. Otherwise, it's pretty straightforward. In fact, this schema file has actually been exported originally from a JDBC schema, so you don't even have to do that manually. Let's see if they started up. Okay, so this is MySQL, I think. And this is Postgres. Yes, they have. Okay, so let's look at the owners. In Postgres, let's look at the owners in MySQL. You can tell that we've already pre-populated it with some data. There's actually a file you can define, which is the auto import. It just automatically federates any SQL data that it finds in this particular import file that you can define, and it has to be somewhere on the class path. So getting back to the matter, let's see how we fared. So, okay, let's open George Franklin and let's open the owner. Don't remember that we share the same code base. So we can just copy the same URL and it would identify the same one because we share the primary key. Okay, so let's edit the owner. So we'll be editing the owner on Postgres. Let's update it on Postgres. Okay, that seemed to have worked. Let's update it. Yes, we refreshed it, and now we find that it's also George 2 on MySQL. Let's do something more exotic. Let's rename Leo. George is Pat to Leo federated. Okay, seem to have gone through. What about Postgres? Is it happy? Yes, it's happy too. Now let's do something radical, and let's kill the Postgres instance. Okay, let's check if it's up. Postgres. No, Postgres is down. Okay, but the good news is that we still have MySQL. So let's edit George again. Okay, so now George is up, George 3, and it has still gone through. Okay, now let's restart my Postgres. Okay, this will take a while, obviously, as it does usually. So what we're demonstrating now is loose coupling. We are showing that even though all of these subsystems can go down, the cluster as a whole can still make progress. So the system is not only atomic, not only distributed, but also supports proper SQL, atomic, consistent, the whole shebang, and is still loosely coupled. Let's see if we have Postgres back yet. Okay, not yet. Maybe. Nope, not yet. No, still doing it. Okay, there we go. George 3. It worked. What do you know? Okay, as a last thing, I'm going to show you the Spring Boot POM XML. We actually added a few things. Quite literally just our own modules. So we have a few modules that you need. You need a Spring integration module to import, and then you need the specific kind of dialect for the specific language that you're using, in which case we're using MySQL and Postgres. That's it. And that's all you need to do to federate an application into different namespaces. I hope you enjoyed this demonstration. Thank you.